Welcome back to The Explainer. Today, we're diving into something that honestly feels like straight-up magic: how our everyday devices actually talk to one another. I mean, we live completely saturated in invisible data, right? Yet, it's kind of rare that we stop and think about the physical nuts and bolts of how a simple text message zips from point A to point B.
You know, historian Yuval Noah Harari actually hit the nail on the head when he said this: "We are merging with our smartphones. Very soon, they will just be part of the body." It's deep, right? We are constantly connected, basically outsourcing our brains and our communication to these little glass rectangles. But while it feels like they're just natural extensions of our minds, they actually rely on a highly structured, very strict physical reality to even function. Which brings us to the big question for today's explainer: how do these devices actually talk to each other? How does a random thought in your head become a typed-out message that instantly pops up on a screen halfway across the world? Well, we're going to step away from the abstract philosophy for a bit and dig right into the tangible, structured reality of network communication.
So here's our roadmap for this explainer. 1. The magic of connection. 2. Anatomy of a message. 3. Measuring the digital highway. 4. Wired and wireless roads. And 5. The rules of communication. Let's get into it. Section 1. The magic of connection.
Okay, so at its absolute core, data communication is just the exchange of information between connected devices. And we're not just talking about two laptops chatting here. Think of it like a giant, diverse ecosystem. You've got your central servers, various computers, and yeah, even that office printer that always seems to have a paper jam. They're all united by a central switch communicating through a medium that literally carries the information from one end of the room or the world to the other.
Section 2. Anatomy of a message. So how does a single piece of data actually navigate that entire ecosystem? Well, we can break it down into 5 crucial pieces. For any kind of communication to happen, you need a sender to generate the data and a receiver as the final destination. Obviously, you need a message to send. Then you need the transmission medium. That's the physical or wireless path it travels on. And lastly, you need protocols, the rules of the road. Literally, if even one of these components is missing, the whole shebang fails. No communication whatsoever.
Let's look at how this plays out in real life, step by step. First up, the sender generates the message. Second, that message travels across your chosen medium, whether that's a physical copper wire or invisible radio waves. Third, the protocol steps in, kind of like a traffic cop, applying the rules so the data doesn't get totally scrambled. And finally, the receiver successfully gets and decodes that data. It's basically a flawless relay race, and it's happening millions of times a second right inside your phone.
Section 3. Measuring the digital highway. To really wrap our heads around this, it helps to imagine network infrastructure as a massive highway system. First up, we've got bandwidth. You can think of bandwidth as the literal width of our digital highway. Makes sense, right? The wider the highway, the more traffic it can handle, all at once. We measure this width in hertz, which tells us the range of frequencies available. So, higher bandwidth simply means more lanes for your data to cruise down.
Now, if bandwidth is the width of the road, the data transfer rate is the speed and volume of the cars actually driving on it. See, data travels in signals, carrying bits. We start down at the bottom with basic bits per second, or BPS. Then we scale up, kilobits, megabits, gigabits, all the way up to those massive terabit speeds. To put that into perspective, a terabit is over 1 trillion bits per second. That number right there, that's the crucial metric that decides whether your 4K movie buffers endlessly or streams flawlessly.
Section 4. Wired and wireless roads. So what are these digital highways actually built out of? Broadly speaking, we're looking at 2 types of media. First, guided media. This is your physical link, stuff like metallic Ethernet cables or fiber optic lines made of glass that quite literally guide light pulses from point A to point B. On the flip side, we have unguided media. This is the wireless stuff, where electromagnetic signals are just traveling invisibly right through the air around us.
Let's break down that invisible, unguided spectrum, starting with radio waves. These operate between 3 kHz and 300 MHz, and honestly, they're the absolute resilient workhorses of wireless tech. Why? Because they can travel incredibly long distances and punch right through solid walls. It's the exact reason why your car's AM/FM radio or an old-school cordless phone works perfectly even when you're deep inside a building.
Now, contrast those radio waves with microwaves. These sit higher up the spectrum, between 1 and 300 gigahertz. Microwaves are amazing because they have a massive capacity for carrying information, which makes them perfect for things like satellite internet and radar. But here's the catch. They are strictly unidirectional. They need a clear line of sight. If a hill, a tall building, or even a thick wall gets between the sender and the receiver, boom,
the signal drops.
Rounding out our tour of the spectrum, we've got infrared waves. These are very high-frequency waves operating way up there between 300 gigahertz and 400 terahertz. They are strictly used for short-distance, point-to-point connections. Because they absolutely cannot pass through solid objects, they're super localized. It's the exact tech making your TV remote talk to your television or your wireless mouse connect to your laptop. It works flawlessly right up until somebody stands in the way.
Section 5. The rules of communication.
Okay, so think about this for a second. With billions of devices sending out terabits of data all at the exact same time, why isn't the internet just total chaotic gridlock? Well, the answer is protocols. As we mentioned earlier, these are the ultimate traffic cops of the digital world. Think of TCP/IP routing your data across the web, or HTTP loading your favorite sites. These rules dictate flow control, they manage access controls so signals don't constantly crash into each other, they make sure every node is properly addressed, and they constantly run error checks to make sure your data packets are reassembled perfectly at the end of the line.
Let's zero in on flow control, because this is absolutely crucial. Imagine a scenario where a sender is blasting out data at a blistering 1024 megabits per second, but the receiver device can only handle 512 megabits per second. Without rules in place, it's like trying to drink from a fire hose. The receiver gets totally overwhelmed, and data is permanently lost. But protocols step in and force the sender to hit the brakes and adjust its speed, guaranteeing a perfectly matched, error-free handshake.
Before we wrap up, let's zoom out and look at the macro future of all this, 5G. This fifth generation of mobile communication, it's not just some minor speed bump. By opening up massive, unguided bandwidth that lets data transfer in actual gigabits per second, 5G is laying down the ultimate wireless superhighway. We're talking about an infrastructure that allows millions of machines, sensors, and even autonomous vehicles to talk to each other seamlessly in real time.
And that brings us right back full circle to where we started. As this machine-to-machine communication rapidly surrounds us, and our digital highways expand to handle terabits of invisible traffic, all flowing flawlessly thanks to these protocols, how seamlessly will we actually merge with this invisible infrastructure? Well, you now have a solid grip on the profound anatomy of the data communication that makes our modern world possible. Thanks so much for joining me on this explainer. Keep asking those big questions, and I'll catch you next time.